This is the AMT Millennium ETH, an Ethernet pulse rate totalizer with analog and digital I/O. Everything you're about to see is done over a standard network connection. This module test application is the configuration and test tool. The application can run on Windows and on Linux. Same application, same screens, and it does not require any runtime or additional drivers installed. At the top, you will see a device IP address and port. The factory default is 192.168.1.222 on port 5000. Once you enter the module's IP address, the application establishes a single persistent connection to the module. The module serves one client at a time, which keeps the interface deterministic. The status line at the bottom provides a visual confirmation of every operation. The first tab is the protocol mode. The module can communicate using two protocols. The first is a simple ASCII scheme, and the second is Modbus TCP, which is typically used with PLC and SCADA systems. The protocol mode shows which protocol is currently active, as well as having a provision to switch a Modbus configured unit to ASCII for servicing via Ethernet, without touching the module. The mode switch function is temporary and needs a 4-digit access code. Selecting the second tab provides pulse rate, counter, and block information. The AMT ETH module measures the pulse period in hardware, so reading doesn't drift with network timing or PC load. One click on the read shows the raw measurement and a calibrated value. Selecting the continuous checkbox will enable the read button to read the data as fast as a communication link allows. This feature allows for watching an active signal and/or proving a pulse sensor. Click again to stop. The calibration feature corrects the measurement time base against a known reference. This is done by providing a precision known frequency to the module pulse input, then entering that value in the reference window. Then click on Calibrate. The application averages a set of samples, computes the correction factor, and then writes that value to the module's non-volatile memory. This takes effect immediately. No reset or power cycle required. A 4-digit access code is required to calibrate and make that change. You can read the stored factor back at any time. Calibration is a bench activity, and as such, a deployed unit cannot be recalibrated remotely, which is deliberate. The AMT Millennium ETH module keeps a 56-bit pulse total in non-volatile memory. This pulse total is retained even on power loss. Due to its large bit size, even at 30,000 pulses per second, will not roll over in any practical service life. You can read the pulse total as often as you like. Reading the pulse total never disturbs the count. The pulse total can be reset or zeroed. However, because it's imperative not to zero the count unintentionally, a 4-digit code is required to perform this function. You cannot zero the counter without the correct 4-digit code. The pulse is not at risk from a stray command or user unintentionally clicking a button. The 4-digit code can be changed by the user. Changing the code requires the user to know the current code to make that change. The module has a documented factory default code, so you're never locked out. For host software, all analog channels and digital inputs can be read in a single transaction using a read block command. This is typically how you would pull the module from a SCADA system or a script. Values can be shown as raw hexadecimal by selecting a checkbox. This is handy when you're writing and debugging your own host code against the protocol. The third tab is I/O. There are 4 analog inputs, read as 12-bit values, 0 to 4095. There are also 3 isolated digital inputs, plus the isolated pulse input. Use this software with a toggling input signal, and you can read it back to see the real state of an input. There are also 3 isolated open collector outputs, which can be switched directly from here. Turn one on and the output follows immediately. The fourth tab is the network configuration. Here you can read the module's configuration, IP address, gateway, and subnet mask. Every module carries a permanent global unique MAC address programmed at the factory. It can be read but never changed. You can set a new IP address and write it. It would then be stored in non-volatile memory and takes effect on the next power-up. If a unit is ever left at an unknown IP address, the factory reset jumper can be used to bring it back to the factory default setting, so you can always establish a way to communicate with the module. The next tab is Firmware Update. Firmware updates can be performed over the same Ethernet link. You can also read the current running version here at any time. A firmware update streams a new image to a separate staging area in the module's memory and checks this before anything is replaced. To perform a firmware update, you will need the 4-digit code. If a transfer is interrupted, the module simply restarts on its existing firmware. A field update can never leave a unit unstable to start. Lastly, there is the Diagnostics tab. This adds 2 bench checks that prove the device can look after its own memory. The flash self-test writes a known pattern to a spare flash row, reads it back and verifies it, confirming the program and read path before you ever send new firmware. The copy engine test goes one step further. It has the module stage a copy of its own running image and restart, so the bootloader copies it back and runs it. Because that stage image is identical to the one already running, it exercises the entire update path end to end with no risk of a bad image. Not shown in this video are 2 onboard module jumpers. The first one is the mode select. This jumper allows the user to configure the module communication protocol, either the ASCII scheme or the Modbus TCP. The jumper is authoritative every time the unit powers up, so it always comes back to its set protocol. The second jumper is factory reset. Factory reset restores the module to its factory IP address and default 4-digit code. While the factory reset is active, the module is in a holding state with a flashing onboard LED. The pulse total and calibration factor remain untouched. That covers the pulse totalizing and rate, analog digital I/O, field calibration, protected counter, and firmware update, all over one Ethernet connection. The tester works a Modbus unit just as easily. It detects the active protocol the moment it connects and shows only the tabs that apply, so a Modbus unit brings up its own I/O, rate, and counter tabs. The same analog, digital, and pulse values read straight from the Modbus registers and coils. It is a quick way to confirm the Modbus map before the unit goes on to something like a PLC. AMD Millennium ETH is engineered and assembled in the USA. It is available as a board-level OEM product. Other options such as DIN rail mount are available upon request.